Okay, we've talked about the traditional algorithm for subtraction, the partial differences algorithm for subtraction, and now we're going to get into the adding up algorithm. Why might we talk about adding up for subtraction? Well, I don't know about you, but every student that I have ever met has better addition skill than they do subtraction skill. So let's maximize that. Let's take that addition skill and apply it to subtraction scenarios. So what might this look like? Let's think about how we could help students add up a problem 52 minus 18. So the first thing we're going to do is draw some vertical lines there to separate the place values. And if you want to use base 10 blocks here, you can. I am not going to on this example. Or I am going to, but you're going to see them in just a minute. So first I'm going to write the subtrahend next to the problem. Here the subtrahend is 18. I like to always remember that is that I subtract the subtrahend. I could not remember that in any other way. And then I'm going to use friendly numbers to add up to 15. So first I ask myself, well, 18 plus 2 is 20. So here you can see I'm bringing in my base 10 blocks like that. I'm not to 52 yet, so then I could think, well, if I add 30, that gets me to 50. I'm pretty close to 52. And if I add another 2, then I now have arrived at that minuend of 52. So what is the difference between 18 and 52? Well, you see it there in my base 10 blocks. You also see it there written on the very far right-hand side of the slide. The difference there is 34. So this helps students solve subtraction problems using their addition knowledge. Now, one of the ways that we might think about using this adding up algorithm is with an open number line. So I'm going to solve the same problem, but solve it in a slightly different way. Let me go ahead and get my marker here so that we can think about, well, what this might look like. So we are going to solve this problem 52 plus 18. And as I said before, we're going to use a number line. So the first thing I'm going to do is draw a vertical line here to separate the place values. It's not as necessary to do that with this problem, but I like to be consistent in my approach to these problems. And then I'm going to write the subtrahend here. So I'm going to write 18 here, but I'm also going to draw that on a number line. So I'm going to go ahead and draw. Oh, that was squeaky. My gosh, probably heard that all the way in Kansas there. And on this open number line, I'm going to place 18 right here. And I'm going to work my way up to, you guessed it, 52. And I think it's going to be helpful if I move over here because I'm going to be kind of between the text and my open number line there. Because I'm standing here, I'm not going to put the text here, but I'm going to now ask myself, well, what can I add to 18 to easily work myself or my way to 52? Well, I'm going to get to a nice even decade. So if I add 2, that gets me to 20, all right? And I could show that over here like we did before. If I add 2, I'm working my way up to 20. All right, now what could I add to 50? Well, I could add 10, 10, 10 to get to 50. So if I add 10 plus 10 plus 10, if I add 30, that gets me to 50. So I could write that right here. Add 30, now you're at 50. We're not at 52 yet, but we're very, very close. How many can I add to get to 52? Well, if I add 2 there, that gets me to 52. I'll go ahead and write that there, and now I'm at 52. Ta-da! We made it. How do we figure out what we added? Well, it's these numbers right here, 2 plus 30 plus 2. That's 34. Or I could add what I drew on my open number line. 2 plus 30, that's 32, plus 2 more is 34. And I can go back to my original problem. Very squeaky right now. Write that there. So what is the difference between 52 and 18? The difference is 34. I really like this open number line for keeping track of this adding up for my subtraction. I sometimes prefer it to this over here. You might do both or you might do one or the other. You really have to figure out what works for you and the students that you're teaching. Now let's use this adding up for a more complicated problem such as 236 plus 89. what would this look like? Well, I'm going to draw those vertical lines to separate those place values, and then I'm going to think about, well, I'm starting at 89 and I want to add up to 236. So let's get to a nice round number. How about thinking about adding 1, that gets me to 90. And if I add another 10, that gets me to 100. And if I keep doing this, I add 100, that gets me to 200. And then I could just kind of take a shortcut, add 36, that gets me to 236. So what is the difference between 89 and 236? Well, the difference is right there. 1 plus 10 is 11, plus 100 is 111, plus 36 is 147. So that was an example of using that adding up algorithm. I'd like you to push pause and consider, would you think about teaching this adding up algorithm to your students? Do you think they benefit from this strategy? Why or why not?